My dear students, I'll read the question. The two masses m and 3m are connected as shown in the figure. The tension in a string is, the figure is given, the diagram is given. So four options is given. Now I'll going to draw the diagram and we will going to be find out the tension. See here, it is an inclined plane, or also we can call as an wedge. Okay, so inclined plane, see here, this is the inclined plane, and now pulley is attached to the top of the inclined plane. One of the block is hanging towards to the downwards, okay, vertically downwards, whose mass is an m, and another block is an hanging on the wedge plane, whose surface is an frictionless. This mass is an 3 mg. Okay, now so tension is an only one tension is there, because one string one tension, so I'll going to take as an T on the both the side. Now the angle of inclination is given as an 30 degrees. Okay, now I'll going to divide the components for 3 mg block, because it is an on the wedge, so it is in downward direction is an 3 mg sin theta, and 3 mg cos theta is equal to normal, so both will get cancelled because the block is not going to be move upward or downwards. So how much 3 mg sin 30? 3 mg by 2. So other side is an only the block is hanging downwards, so vertically downwards, that is an mg is a force. Okay, so now whose mass greater? So 3 mg by 2 mass is greater, so that's why the system will move with the acceleration towards to the 3 mg by 2 direction, and upward direction at the mg block. So A net is equal to how much, my dear? A net is equal to F net upon M net. How much the F net? F net is equal to, my dears, 3 mg by 2 minus mg upon M net. M net is equal to 3m plus m, that is an 4m. Understand? So now m, see here, all the sides m get cancelled. Now what is the remaining here? The remaining is, that is an 2g plus 3g. So 2g, so 3g minus 2g, that is an g only remains, and g by, see here, 4 to ja 8. So A net is equal to g by 8 meter per second square. Now the tension for the free body diagram I am going to draw here for the m block. Okay, so upward is an T and downward is an mg. So acceleration is an upward direction, so T is a greater, so that's why T minus mg is equal to ma. How much m? M is an m, a is an, we already find out, that is an g by 8. So T minus mg is equal to mg by 8. So now T is equal to how much, my dear? Mg by 8 plus mg. Yes or no? Mg by 8 plus mg. How much it is? 8 mg plus mg. 9 mg by 8 is the answer. So that is equal to, T is equal to 9 by 8 mg. Understand? 9 by 8 mg. Okay, so the option is an, second option is an correct answer. Now I am going to read the question. The three equal weights A, B, C and mass 2 kg each are hanging on the string passing over the fixed frictionless pulley as shown in the figure. The tension in a string connected weight B and C is nearly. So now I am going to draw the diagram. See, we are going to be find out the tension. So the diagram is given as an, see here. So this is one mass, and another side two masses is hanging. Yes or no? So he said that each mass is an, he already said. Yes or no? See here, how many strings are there, my dear? There are two strings are there, so two tensions will be there. So each mass is an 2 kg. So this is also 2 kg and this is also 2 kg. How many strings are there? 2 strings are there. So 2 strings, 2 tensions. So that is why I am going to taking as an, this is an as a T1, and another string tension I am going to take as an T2. Okay. So now, so which side the acceleration will be there for the system? That is an 2 block sides. Yes or no? So because this side is an 2 to 4 kg is there, and another side is an only 2 kg is there. So blocks name I gave as an A, B, C. So the acceleration will be in the direction of BC. Okay. So now A net is equal to how much, my dear? F net upon M net, we know very well. Yes or no? See. So I am going to draw the direction of acceleration. Yes or no? So BC block will come downwards and A block will go upward with an A acceleration. Now F net is equal to how much, my dear? So it will come as an 40 minus 20 upon total M net. M net is equal to 6 kg. That is equal to how much, my dear? 20 upon 6. Yes or no? That is equal to how much it is? So 2 3 ja 2 10 ja. So that is an 10 upon 3 meter per second square. Understand? So now we have to find out the tension in between of B and C. I am going to draw the free body diagram. See here. So this is a 2 kg block. So downwards is an 20 Newton and upward is an T1 tension. Okay. So acceleration is an downwards. So that's why 20 is an greater. So 20 minus T1. Yes or no? It will come as an, 1 second. So see here, 20 minus T1 is equal to MA. 2 into A. A is how much? We know very well. That is an 10 upon 3. So T1 is equal to 20 minus 20 by 3. Yes or no? 2 into 10 by 3, that is nothing but 20 by 3. So that is equal to 60 minus 20 upon 3. So that is equal to how much, my dear? 40 upon 3. Yes or no? So that is an tension T1. So how much the value will come? See here, the T1 40 by 3 is nothing but the value will come approximately. See here, T1 is equal to, it will come as an 13.3 Newton. Okay, so that is the value of T1. If you want, we can able to find out the T2 as well. Nothing to worry. So we have to take A block and we have to draw the free body diagram, and we can able to find out the T2 also. Yes or no? Yeah, it is very easy. So see here, I am going to drawing the diagram for T2 as well. See, this is an 2 kg block, and now tension is an T2 is an upward and downward is an 2g, that is an 20. So acceleration is an upward direction. So 2t is greater. So that's why T2 minus 20, yes or no, is equal to MA. 2 into A. A is equal to how much? 10 by 3. So T2 is equal to 20 upon 3 plus 20. So that is equal to how much, my dears? 60 plus 20. Yes or no? Otherwise 20 plus 60 by upon 3. So total is an 80 upon 3. Yes or no? Are you understand? So that is the value of T2. So T2 is equal to 80 upon 3. So this value will come approximately, T2 is equal to, okay, see here, T2 is equal to It will come as an 26.6 Newton. Okay, but he asked only about the T1, but we find out T2 as well. Understand? So the option is an correct option is second option is a correct option. Okay, hope you understand. Okay, I am going to read the question. A body of mass 60 kg is holding a vertical rope. The rope can be break when the mass of 75 kg is suspended from it. The maximum acceleration with which the boy can climb the rope without breaking it is. So G value is taken as 10 SI units. Okay, 10 meter per second square. So 4 options are given. Okay, I am going to draw the diagram and we can able to find out the acceleration with which he can able to climb. Okay, so this is the rope. Okay, so I am going to drawing the rope here. So this is the rope, and who can be able to bear the weight is an 75 kg. That means how much the weight is an 750 Newton. Yes or no? If you apply the 750 Newton, it cannot be break. So now a man is climbing up the rope. Yes or no? Whose mass is an? He is already given in the question. The mass of the man is 60 kg. Okay, now what is the weight of a man? The weight of the man will come as an 600 Newton. Yes or no? So mg is equal to 600 Newton. So now when he is climbing up, the acceleration is upward direction. So the force will act downwards, that is equal to ma. Yes or no? Are you getting my point? So ma is equal to 60 into a. So this a value we have to find out. 60 is the mass of a man. Okay. Now see here, tension T is equal to how much, my dear? ma plus mg. So if you take a common m, then g plus a. Yes or no? So tension is already given, breaking tension, that is an 750 Newton, that is equal to mass is given as an 60 kg. Mass of the man is an 60 kg. Yes or no? Okay, see here now, mg is equal to 750 Newton will come. So 750 is equal to now 60 into 10 plus a. So now 750 upon 60, so 0 0 get cancelled, that is equal to 10 plus a. So a is equal to how much, my dear? 75 upon 6 minus 10. So 75 minus 60 upon 6. Yes or no? So a is equal to, the value will come, 1 second, the value will come as an a is equal to 75 minus 60 upon 6, that is equal to 15 upon 6. Yes or no? So that is equal to how much the value will come, my dear? So if it is get 3 2 is 6, 3 5 is 15, 5 by 2. So 5 by 2 is nothing but, yes or no, approximately it will come as an 2.5 meter per second square. Yes or no? So the option is, first option is a correct option. Okay, hope you understand that. Now I am going to read the next question. The apparent weight of a person inside a lift is W1 when the lift is moving up with a certain acceleration, and is W2 when the lift moving downward with the same acceleration. The weight of a person when the lift move up with a constant speed is. There are 4 options is given. Okay, so I am going to draw the lift. Okay, free body diagrams. So lift cases, if you don't know, then you can go for my lift cases in Newton laws of motion. You will going to get the video, so you can understand from there. So now see, this is the lift, and a man is standing in a lift, and lift is moving up with the acceleration whose normal is given as an W1 apparent weight. So second case is an downward direction with the same acceleration, that is an A, I took as an A. So whose apparent weight is an W2. Yes or no? See now. So the lift cases, this is an case 1, let it be, there is an case 2. So 2 cases are there. So I am going to write the first case. So now W1 is equal to, so mg plus A. Yes or no? mg plus A. Okay, when the lift is moving upward. So when the downward, W2 is equal to mg minus A. Yes or no? So actual weight is an W is equal to mg. Yes or no? Actual weight of the man is equal to W is equal to mg. So now this is an equation 1 and now this is an equation 2. So 1 plus 2. So how much it is, my dear? That is equal to W1 plus W2. Okay. So I am going to write here W1 plus W2 is equal to mg plus ma plus mg minus ma. See, minus ma plus ma get cancelled. Yes or no? How much the remaining here? W1 plus W2 is equal to L2mg. Yes or no? So W1 plus W2 upon 2 is equal to mg. So 2 is, I send this side, it will come in the denominator. So what is the value of mg? Mg is nothing but W. So W is equal to W1 plus W2 upon 2. That is the answer. Okay. Do you understand now? See here now. So if the lift is in moving upward or downward with a uniform velocity, okay, then apparent weight will be an, see here. So if an uniform velocity, if it is going uniform velocity, what will happen? We are going to discuss. See here, moving up or moving down, okay, with uniform velocity or constant velocity, then what will happen? Now the apparent weight is equal to actual weight. So W dash is equal to actual weight. That means W dash is equal to W when the body is in rest, moving upward, downward with a constant velocity. Now our option is an, first option is an correct answer, that is an W is equal to W1 plus W2 by 2. Okay, hope you understand that.